Question number 1. A block of mass 15 kilograms slides down a line of greatest slope of an inclined plane. The top of the plane is at a vertical height of 1.6 meters above the level of the bottom of the plane. The speed of the block at the top of the plane is 2 meters per second, and speed of the block at the bottom of the plane is 4 meters per second. Find the work done against the resistance to motion of the block. So we have to draw first to illustrate the equation. A block of mass 50 kilograms slides down of line greater slope. So this is a slope. There is a block, slides down. The top at the vertical height of 1.6 meter. So this is 1.6 meter. The speed at the top, so V equals to 2 meter per second. And the speed at the bottom, so the speed at the bottom here will be 4 meter per second. Find the work done against the resistance to motion of the block. So in here, we can solve this equation by using the energy method. So on the top, we have gravitational potential energy, since the block is in the position of 1.6 meter above the ground. And we have kinetic energy, because the block has a velocity of 2 meters per second. At bottom, we have kinetic energy and the work done against the resistance. So by using the law of conservation of energy, so PE plus KE at the top will be equal to KE and work done at the bottom. So the PE is mgh plus half mv squared equals to half mv squared plus work done against the resistance. So we can just put all the information here. So 15 times 10, the gravity, times 1.6 plus half times 15 times 2 squared equals to half times 15 times 4 squared plus the work done against the resistance. So we can just calculate. So it's 15 times 16, so 240 plus 30 equals to half times 15 times 16, so 15 times 8, 120 plus work done against the resistance. So the work done against the resistance is 240 plus 30 minus 120. So equals to 150 joules. Number 2. The diagram shows a smooth ring R of mass M threaded on the light inextensible string. A horizontal force of magnitude 2 acts on R. The ends of the string are attached to a fixed point A and B on the vertical wall. The part AR of the string makes an angle of 30 degrees with the vertical. The part BR makes an angle of 40 degrees with the vertical and string itself. The ring is in equilibrium. Find the tension in the string and find the value of M. So this string is a light inextensible string. So this is only one string. If we have one string, that means the tension of the string will be equal. If there are different strings, so the tension will be different. But since this is only one single string, So the tension will be the same. So now let us consider all the forces here. So from the mass, we will have weight, mg here. And for the tension, we can split the tension into here and here, as well as the vertical up here. So if we have 30 degree, so I have 30 degree here. So this will be T cos 30. And here will be T sine 30. As well as here 40, so this will be 40 degree. So here will be T cos 40, and here will be T sine 40. So now, since they are in the equilibrium, so I can write for the horizontal component, the total force will be equals to 0. So 2 newtons to the right will be equal, because they are equilibrium, will be equal to the forces to the left. So it's T sine 30 plus T sine 40. That's for the horizontal component. And for the vertical component, the resultant force will be equals to 0 as well. The resultant force are on the upwards T cos 30 equals to the downward forces T cos 40 plus mg. So we need to find the tension and the mass. So since we have two unknown variables and two equations, so we can do simultaneous equation. So I can find the tension first from the first equation. So it's 2 equals to T sine 30 plus sine 40. So T will be equals to 2 over sine 30 plus sine 40, which is equals to, we use calculator, so 2 over sine 30 plus sine 40. So 1.75 newtons. And then we can put this value to the second equation. So I can change the position. T cos 30 minus T cos 40 will be equals to mg. So T cos 30 minus cos 40 equals to 10m, since g is equals to 10. So that means I can just put it 1.75 times cos 30 minus cos 40. So we have to use the real answer for this, yeah? 1.75, 0.1. So I just take 5 significant figures equals to 10m. So m will be equals to, so the answer times cos 30 minus cos 40, and then divide by 10 equals to 0.0175 kilogram. So these are the answer for number 2. Number 3. A block of mass 10 kg is at rest on rough plane inclined at angle 30 degrees to the horizontal. A force of 120 newtons is applied to the block at the angle of 20 degrees above the line of greatest slope. There is a force resisting the motion of the block and 200 joules of work done against this force when the block has moved a distance 5 meters up the plane from rest. So it's travel for 5 meters, start from rest. Find the speed of the block when it has moved the distance 5 meters up the plane from the rest. So first we can split this 120. So here will be 120 cos 20. This one will be 120 sine 20. And this will be the weight. It's 10 times the gravity. It will be 100 newtons. And then if we split the weight components, it will be 100 cos 30 and 100 sine 30. Now, there is a force resisting, and 200 joules of work is done against this force. So we can find the speed using the energy method. So we have to compare between this position and this position, the final position, when it's level 5 meters. So I will use this the energy. Or maybe it's easier if I use the kinematics, yeah? So first, we have to find the resistive force. So the work done is equals to the force, resistive force, times the displacement. So the work done is 200 equals to F times displacement is 5 meters. So the resistive force is 40 Newton. So we have another 40 Newton as the resistive force here. And then using the Newton's law, sigma F equals to ma. So we find the acceleration. So sigma F equals to 120 cos 20 minus with 100 sine 30 minus the resistive force 40 equals to the m is 10 times a. So a here will be equals to 120 cos 20 minus 100 sine 30 minus 40. And then divide by 10. So it's 2.2763 meter per second square. And using this acceleration, we can find the speed. So we can use v square equals to u square plus 2as. So v square equals to u is 0 plus 2 times a, 2.2763 times 5. So equals to this answer times 2 and then times 5. Yeah, so this is 22.763 for the v square. So the v is, you root this answer, so it's 4.77 meter per second. That's the answer for this. Number 4. A particle P of mass 0.2 kg lies at rest on a rough horizontal plane. A horizontal force of 1.2 newtons is applied of 2p. Given that P is limiting equilibrium, find the coefficient of friction between P and the plane. A particle of mass lies on the rough horizontal plane, so we draw it here. So 0.2 rough. And then there's a horizontal force, 1.2 newtons applied to P. So it will be like this. 1.2 newtons. P is limiting equilibrium. So that means the friction will be here and the resultant force will be equals to 0 for the limiting equilibrium. So that means 1.2 minus friction will be equals to 0. So that means the friction will be equals to 1.2. The friction is mu times normal is 1.2. So the normal will be here, which is equals to the weight. So 2 newtons is the weight. So that means mu times 2 newtons equals to 1.2. So mu is 1.2 divided by 2 is 0.6. B, given instead that the coefficient of friction between P and the plane is 0.3. Find the distance traveled by P in the third seconds of its motion. So third second means it's from 2, t equals to 2 until t equals to 3. So we can find the acceleration first. So now the coefficient of friction is 0.3. So that means the friction will be 0.3 times 2 equals to 0.6. And sigma f equals to ma. It's no longer in limiting equilibrium. So sigma f will be 1.2 minus 0.6 equals to the weight, the mass is 0.2, 0.28. So 0.6 equals to 0.28, so A equals to 3 meter per second squared. Now we find the distance traveled by the third seconds of its motion. So we have initial speed, yeah, at rest. So initial speed is 0. So we can use how far is it? Okay, so we can find between the two, the time t equals to 2 and times equals to 3. So when t equals to 2, I can use s equals to ut plus half at squared. So u is 0 plus half times 3 times 2 squared equals to 2 times 3, 6 meters. When t equals to 3, so s equals to ut plus half at squared, which is the same. So 0 plus half times 3 times 3 squared. So it's 27 over 2. So that means the distance between the third seconds is equals to 27 over 2 minus 6. So 27 over 2 minus 6 equals to 7.5 meters. Five. A particle of mass 0.5 is projected vertically upwards from horizontal ground with speed 25. So this is speed is 35, 0.5 kilogram. Find the speed of A when it reaches a height of 20 meters above the ground. So this is the 20 meters. So we can find using the formula speed, yeah, v square equals to u square plus 2as. So v square, u square is 25 square plus 2a is gravity. So negative 10, s is 20. So the v will be equals to 25 square minus 400. So it is 15 meter per second. When A reaches a height of 20 meters, it collides with a particle B of mass 0.3. which is moving downwards in the same vertical line. So at the 20 meters, the velocity is 15 meters per second, and then collide with B with speed 32.5 meters per second downwards. So they are in opposite direction. In the collision between the two particles, B is brought to instantaneous rest. Show that the velocity of A immediately after the collision is 4.5 meters downwards. So we have to find the condition after the collision. So after the collision, it will be like this, A, B. So A will be 0, and B will be 0, and A will be unknown. So we have to find the speed of A. So using the law of conservation of momentum. So the momentum before collision will be equals to the momentum after collision. Momentum before collision is the momentum of A and B. So momentum MA/VA plus MB/VB equals to MA/VA after the collision plus MB/VB after the collision. So we put the weight. Mass A is 0.5. So 0.5 times 15 plus mass B is 0.3. 0.3 times negative 32.5 since B is downwards equals to 0.5 times VA after the collision plus 0.3 times 0 B after the collision. So calculate this, 0.5 times 15 minus 0.3 times 32.5. So it's negative 9/4 equals to 0.5 VA prime. So VA prime will be equals to negative, so divide by 0.5, 4.5 meter per second. So it's shown. Negative means downwards. C. Find the time interval between A and B reaching the ground. You should assume that A does not bounce when it reaches the ground. So from the previous question, A and B are meet at the height of 20. The velocity of A is negative 4.5 meter per second, means it's going down. B is stationary. So we need to find the time between A and B. So I can find A first using the formula St equals to S0 plus Ut plus half AT squared. So St will be the final at the ground. S0 will be the initial, 20, plus U is negative 4.5 times TA, plus half times negative 10 TA squared. It's negative 20 equals to negative 44.5 TA minus 5 TA squared. I can simplify TA squared, 5, yeah, 5 TA squared plus 4.5 TA minus 20 equals to 0. So we can solve this using the formula to find the TA. So if we use the formula, it will be negative 4.5 plus minus square root of 4.5 squared minus 4 times 5 times negative 20 over 2 times 5. So equals to 4.5 squared plus 20 times 20 and then you root it. So it's minus 4.5 divided by 10. So it's 1.6 seconds. Here we take the positive one. B, so the same formula, initial plus ut plus half at squared. So the 0, 20 plus 0 plus half times negative 10 times tb squared. So it's 20 equals to 5 tb squared. So tb will be 2 seconds. So the time interval will be 2 minus 1.6 seconds, so 0.4 seconds. Number 6. A railway engine of mass 120,000 kilograms is towing a coach of mass 60,000 kilometers up a straight track incline at an angle theta. So I draw it. Alpha. So 120,000 coaching a mass of 60,000 kilograms. Where sine alpha equals to 0.02. There is a light rigid coupling parallel to the track, connecting the engine and coach. The driving force produced by the engine is, so the driving force is 125,000 Newton, and there are constant resistances to motion of 22,000. So 22,000 and 13,000 newtons. Find the acceleration of the engine and find the tension in the coupling. So that means we have to split all the components. So this is the weight. So we have this one. So we have 1200000 cos alpha, 1200000 sine alpha, as well as this 60,000 times gravity sine alpha. Okay, and then so we can find the resultant forces. The resultant force equals to ma. So the driving force minus with the weight, so 1,200,000 sine alpha minus another one, 600,000 sine alpha minus the resistance, so 22,000 and 13,000. So equals to the total mass. The total mass will be 120 plus 60, so it's 180,000 times 8. And we can put the sine alpha as 0.02 here. 0.02, 0.02 here. So I can find the value of A. The A will be 125,000 minus 1,200,000 times 0.02 minus 600,000 times 0.02 minus 35,000 and then divide by 180,000. So equals to 0.3 meter per second square for the acceleration. And for the tension, so I can see 1. So I can see this one, the tension. This is the 60,000 kilograms. 13,000 for the resistance. And I have the weight component here as the 60,000 times 10 sine alpha. So the sigma F equals to MA. So it's T minus 13,000 minus 600,000 times sine alpha equals to 60,000 times 0.3. So I can find the T. So the T is 60,000 times 0.3 plus 13,000 plus 600,000 times 0.02. So it's 43,000 newtons. That's answer number A. At an instant, when the engine is traveling at 30 meters per second, it comes to a section of track inclined upwards at an angle beta. So now it has angle beta, yeah? So the same, 120,000 and 60,000 with 13,000 resistance and 22,000. So when the speed is 30 meters per second, it comes to section. The power produced by the engine is now 4,500,000 watt. And as the result, the engine maintains a constant speed. Assuming that the resistance forces remains unchanged, find the value of beta. So we know that the power is equals to force times velocity. Since the velocity is constant, and we can find the driving force that pull these two objects, the engine and the coach, up with the constant speed. So we have to find first, it's 4,500,000 equals to F times the velocity. So the F will be, so it's 15,000 newtons. So that means the resultant force will be equals to 0 since this is a constant speed. So 15,000 minus weight component, so 1,200 sine beta minus 600,000 sine beta minus the frictions 13,000 minus 22,000 equals to 0. So I can connect this sine beta. So 150000 minus 13,000 minus 22,000. So it's 115,000 minus 1,800,000 sine beta equals to 0. So sine beta here will be 115,000 over 1,800,000. So this divided by 1,800,000. So equals to 0.06389 and find the value of beta. So the beta is the sine inverse So it's 3.663 or 3.7 degree. One decimal place for angle. Number 7. Vertical x travel in straight line. Velocity x at the time t leaving the fixed point O is denoted by v, where v equals 2. The acceleration of x is 0 at t equals to p and t equals to q, where p is smaller than q. Find the value of p and the value of q. So the acceleration is 0. So acceleration is the first derivative of the velocity. So the acceleration is, so you multiply, it's negative 0.3 t squared plus 3.6 t minus 6. And this is equals to 0, according to the question, at p and q. So we can simplify this, divide by 0.3, so it's t squared minus 3.6 divided by 0.3. Yeah, divide by negative 0.3, so I change all the signs. So it's 12t plus 6 divided by 0.3 is 20 equals to 0. So I can factorize. So t to make it 20, so t minus 2 and t minus 10. So t equals to 2 and t equals to 10. So p will be the smaller one, 2, q will be 10. It is given that the velocity of x is 0 at t equals to 14. Find the velocities of x at t equals to p, t equals to q, and hence sketch the velocity time graph. So the velocity is 0 at t equals to 14. The velocity at t equals to p. So when t equals to 2, the velocity is, so you just replace to the equation, negative 0.1 2 cube plus 1.8 2 square minus 6 times 2 plus 5.6 equals to negative 0.1 times 8 plus 1.8 times 4 minus 12 plus 5.6 of 0. And t equals to 10, v will be equals to negative 0.1 times 10 cubed plus 1.8 times 10 square minus 6 times 10 plus 5.6. So negative 0.1 times 1000 plus 1.8 times 100 minus 60 plus 5.6 equals to 25.6. And when t equals to 14, v equals to 0. So now we draw. This is t, this is v. When t equals to 0, the velocity will be 5.6. So when t equals to 0, it will be 5.6. When t equals to 2, it will be 0. When t equals to 14, will be 0. When t equals to 10, will be 25.6 here. And this is 15. Now, the velocity is 0 at t equals to 2 and 10. So that means it reaches the maximum or minimum velocity when t equals to 2 and 10. So it will minimum in 2 and maximum in 10. So it will be like this. Like this. So this is the sketch. And find the total distance traveled by x between 0 and 15. So according to the sketch that we have, the distance traveled will be the total area under the graph here. And we see that in this case, it will be a negative. So we have to ignore the negative here. So the total distance will be integral from 0 until 14, negative 0.1 t cubed plus 1.8 t squared minus 60, is it correct? Plus 5.6. dt plus absolute value of integral from 14 to 15, the same formula, plus 1.8 t squared minus t, 60 plus 5.6 dt. So we ignore the negative here. So now we just calculate. So it is negative 0.1 over 4 t4 plus 0.6 t cubed minus 3 t squared plus 5.6 t from 0 until 14 plus absolute of negative 0.1 over 4 t4 plus 0.6 t cubed minus 3 t squared plus 5.6 t absolute value for the 14 until 15. And we do calculate. So I can just put 14 here, negative 0.1 over 4 times 14 to the power of 4 plus 0.6 times 14 to the power of 3 minus 3 times 14 to the power of 2 plus 5.6 times 14 minus 0. So 176, 2 over 5 minus 0 plus you put 15 and you put 14. So it's negative 0.1 over 4 times 15 to the power 4 plus 0.6 times 15 to the power of 3 minus 3 times 15 to the power of 2 plus 5.6 times 15. This one will be equals to 8.025. Yeah, the result is negative, but we put the absolute sign, so it will be positive. So equals to 176.4 plus 8.025. So equals to 184.425, since this is exact answer. Okay, so that's all for this question. Thank you.